So for number 6, we have that two schools are represented by the points 2,20, which is this guy here, and 14,24, which is this guy here. Then they tell us that we have a road represented by the line R with the equation of negative x plus y equals 4. See? And we have then an architect is asked to determine the location of a new bus stop on the road such that it is the same distance from the two schools. So there is some point along this line where this distance and this distance is the same, or this and this is the same, or this is the same. See? So that is our mission. It's pretty intimidating. Let's go step by step, see what the problem asks for. Part A. Find the equation of the perpendicular bisector of AB. Give your equation in the form of y equals mx plus c. So, first things first, what the heck is a perpendicular bisector? So, the familiar word, or probably more familiar word, is the word perpendicular. See? So let's remember that perpendicular looks something like this. Perpendicular to r would be that. Perpendicular to x-axis would be that. Perpendicular to y-axis would be that. ¿Cierto? Perpendicular to, I don't know, this line is that. So what's special about it? Well, a couple of things. But what I want you to keep in mind for now is that the slope of perpendicular lines is this. The slope of my first one times the slope of my second one has to equal -1. See? So in a certain way, you can actually say that the slope of one is going to be, you multiply negatively and you flip it. See? So that is kind of like the intuition, or so to say. This is the mathy way to like remember it. There's a couple intuitive ways to remember it. Whatever. See, whatever floats your boat. But this is what the fact of that it's perpendicular. That's what it tells us. See, so if it's perpendicular, that's what it's telling us. That's how the slopes interact. The fact that it's a bisector is a little bit different. See, and so in its name, bi is for two. Cierto sector. We're gonna be cutting it up into sectors. And so the bisector of R would be something like this, cierto? A line like that, where this distance here is the same as this distance here. See? The bisector of my x-axis right now would be something along this line, where 0 to 12 is equal to 12 to 24. See? So that is the intuition of a bisector. So we're talking about the bisector of AB. So let's take a moment. Let's draw the line AB, which goes something like that. So the bisector of AB, you're probably already imagining it, is going to be something like that. See? Okay, so this distance would be the same as that distance. Now, why is it important that it's perpendicular? Well, first of all, it's useful information. But second of all, you could, in theory, ¿cierto?, have a bisector that goes like that. It looks much more weird, but it still completes the property that, hey, this distance is the same as that distance. See? This is still a bisector. It's not a perpendicular bisector. Perpendicular bisector probably looks something like that. See? So that is my current scenario. We need to find that line. We need to create that line. How do you create lines in this world? So for creating lines in this world, there's a couple equations we can use. See? And so if you open up your formula booklet, you're actually going to find a couple. For equation of a straight line, we have these three guys here. See? And so just so that we're all on the same page, we need it in this form there. See? We need it in the form of y equals mx plus c, because that is what the problem is asking for. ¿Cierto? Now, I'm going to give you a tip. See? Always, 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 always. It might take a couple extra steps, pero always, always go with the point slope form, which is this last guy here. See? This last guy, all you need, literally all you need is the slope, which is m, and a set of points, which is the x1, y1, which we're seeing there and there. See? So if you have just the slope and just a set of points, boom, you can create this. And now, I know you may be thinking, okay, but I need it in this form here. Why don't I just use that form? Well, because it's hard to use that form right away. What's always going to work is what I'm trying to say. What's always going to work is that you do the point slope form and you jump from here to here, or you jump from here to here. All you're going to do is move some terms around and you're going to get to those forms without a problem. See? And so we have to find the slope and the set of points in order to make this work. Let's go with the slope first. ¿Cierto? And so slope is equal to gradient. So slope equals gradient. And the formula for that is right there. ¿Cierto? So y2 minus y1 divided by x2 minus x1. All right. So slope of AB ¿cierto? Is y2 minus y1 divided by x2 minus x1. See? Now, as I said earlier, x1, y1 makes reference to set of points. See? If you have x1, y2, this does not work. See? It does not work because it's not consistent. Notice that I'm being consistent with 1 here, ¿cierto? So, my point A is going to be my first point because I chose it to be that way. X1 will be 2, y1 will be 20. X2 will be 14, y2 would be 24. If you wanted to, you could flip this around. Like dead ass. You can say that this is x2 and this is y2, or that this is x1 and that this is y1. What you cannot do is have x1 with y2 or x2 with y1. See, that is where things get illegal and stuff does not work out. See? So again, just be consistent. You define it whichever way you want. Anyways, we're coming back to what I mentioned earlier, x1, y1, x2 is 14, y2 is 24. See? So having that in mind, I'm going to plug it in. We end up with 20 minus 24. Oops, I already messed it up. 24 minus 20 divided by 14 minus 2. See? So this will give me 4 divided by 12, which is the same as 1/3. So this is the slope of AB. See? Now we know that this is perpendicular, right? And so the slope we're trying to find is the perpendicular to the slope of 1/3. See? So using this property here, we actually have 1/3 times m2, which is the slope of my guy in red. This guy red here. Equals equals -1. See? And so I multiply times 3 to both sides in order to get m2 alone. I end up with m2 being equal to -3. See? So this m2 makes reference to the slope of my red guy. Got it? So right now we have the slope we were asking for. See? So slope red guy is -3. What we need now is a set of points, ¿cierto? So once we have a set of points, we can use the point slope formula that I was talking about earlier because it's the only two things we need. We already have the slope. Now we need the set of points. See? So how can we find the set of points here? Well, we know that we are dealing with a bisector, ¿cierto? And so we know that this perpendicular bisector is cutting right through the middle of AB. Right through the middle. So we are talking about a midpoint. To the Batmobile. What is the midpoint formula? Right there, ladies and gentlemen. Right there. So this is the one we're going to be using now. This is all your formula booklet. Get familiar with it. Identify the buzzwords. It is very useful. So, midpoint formula. I'm kind of running out of space here, but I'll figure it out. So, midpoint is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. See? So we said that x1 was 2, ¿cierto? So we have 2 plus x2. We said it was 14 divided by 2, comma, y1 was 20 and y2 was 24. See? So we have 20 plus 24 divided by 2. So we work this out a little bit. We end up with 16 divided by 2, comma, 44 divided by 2. We develop this a little bit more, and our midpoint is going to be 8, comma, 22. So this is my big point M. 8, 22. We're talking about this point here is 8, 22. So why did we do that? Again, just so that we can use this guy over here in my formula booklet, as I showed you earlier, equations of a line. See? So now that we have the slope, now that we have a set of points, we can plug into the point slope formula. The point slope formula we said was y minus y1 equals m times x minus x1. See? So my x1 is this, my x1 is this guy, my y1 is this guy. See? So y minus y1 equals slope -3 times x minus 8. See? Slope is -3 because it's what we identified all the way back here. Slope of the red guy, which we got from this here, which came from this, which came from that. Cool. So y minus 22 equals -3x because I multiplied -3 times x plus 24 because we have -3 times -8. I want to get y alone. Why do I want to get y alone? Because this here is y equals mx plus c. And so we know that we have to get y alone, and everything else will just kind of like float into place. So I'm going to do plus 22 to both sides, see what happens. y equals negative 3x plus 46. Ladies and gentlemen, that is the equation of the red line. This is the equation of my perpendicular bisector. See? So again, follow the process, go for the point slope formula. I'm telling you, this guy will be your savior multiple times. See? So that is for part A. Part B tells us to determine the coordinates of the point on R where the bus stop should be located. All right, so the point, so because this is the perpendicular bisector, the guy in red, wherever that lands here is going to be equal distance from the both schools, ¿cierto? Why? Because the kids will drop off here, walk the same distance, and walk the same distance again from A to B. And so that's fair. It's completely fair. They are walking the same distance. In fact, this and this would also be the same distance. See? So um wherever my perpendicular bisector touches my line R is where is where the bus stop should be created, is what I'm trying to say. See? So that is why we did part A in the first place. See? So where do these lines meet is what I'm asking for. Where do they intersect? There's a couple ways to do this, but the first thing is identifying, okay, my first line has this form here. ¿Cierto? So my first line has, I'll just do it down here, see? It's negative x plus y equals 4. See? So this is my first line. My second line is y equals negative 3x plus 46. So there's a lot of different ways that you can solve this from here. You can use your calculator, calc intersect, ¿cierto? You can also use you can just kind of like do it by hand. I'll show how to do it by hand. I think it's like a little bit quicker. But hey, there's a lot of ways to do this from here. See? The first thing is that you want these two equations to look similar, ¿cierto? So the best way is to have y equals on both of them. I have y equals on the bottom. Let's have y equals on top. So y equals on top would be like this. Y equals x plus 4. See? So all I did was add x to both sides. See? So now that I have them in a similar form, I can use a system of equations. ¿Cierto? This probably sounds familiar. System of equations, I can either substitute, I'm not writing that well at all, or eliminate. See? In this case, I think it's a little bit better to substitute because you already have y on both sides. See? So this y here is going to be plugged in there to the other y. ¿Cierto? And so if I do that, I end up with x plus 4 equals negative 3x plus 46. Okay, why is this useful? Well, before I would have two variables. ¿Cierto? I have one variable, another variable here. I could never get them alone. ¿Cierto? Instead, down here in orange, I have it all in terms of x. ¿Cierto? There's only x's going around, so I can find x equals a number. Before I could not find x equals a number, I would always have a y going around, and it was very complicated. See? So we want to get to x equals in this case. I'm going to throw everything to the left side in terms of x's. So I'm going to do plus 3x, 4x plus 4 equals 46. 4x equals 42. That happened because of minus 4. See? Let's get x alone, divide both sides by 4. We end up with x being 10.5. See? Cool. So now we need to find what y is, ¿cierto? And now that we have a value for x, getting y is actually super duper easy. I can plug in this value here into either this guy. Whoops, apparently that's not going to work. I can take this value here and plug it into this guy here, or this guy here. I get the same answer. I'm going to do it to the one on top because clearly it's way easier. And so doing that, we end up with y equals 10. Sorry, my value of x, which you said was 10.5. So 10.5 plus 4, y has to be 14.5. See? So that is my x comma y, which is the location of my bus stop for where the bus stop should be located. See? So my answer finally would be 10.5, comma 14.5. That is how you do number 6.